Hi, welcome to Knowledge Center. In this session, we are going to study about Module 4 of Microcontroller subject. So Module 4 in that microcontroller consists of serial port programming and also interrupt programming. So we all know that there are 6 interrupts in microcontroller. Among that, serial port is also one of it. So first let us begin with the serial communication in a microcontroller. So before moving on to the programming part of a serial communication, we need to understand what is this serial communication and why we are preferring serial communication in microcontroller. Because when we talk about communication, there are two possibilities. Means we can communicate either serially or parallelly. In the sense, if you are having an 8-bit of data which is to be communicated with some other device. For example, let us take a computer and a printer. Printer means whatever the input we give in the computer, that has to be printed out. So there should be a communication between a printer and a CPU, right? So how this communication will be done, whether we are going for a serial or parallel, and which one is better, let us understand that. So first let's see what is happening in parallel. So if it is of an 8-bit data, we need to have an 8 wires to be transferred at a time. So parallel in the sense, so this is a device and your receiver, and let us assume this is a transmitter from which we are transferring the data. So if you want to transfer 8 bits of data parallelly, then we need to have 8 lines or 8 transmitting wires. Okay, so this say 1, 2 and this is 8th. So we need 8 number of lines to transfer 8 bit of data. But the advantage here is we are transferring all the 8 bits at a time or simultaneously. So the speed is going to be high, or we can say this is fast. But the problem here is to transfer that 8-bit data, we are making use of an 8 wires. Definitely the cost is going to be high. And also if there is any problem in any of the one wire, the data will be insufficient data will be sent. Okay. So the cost of this system will be high. And this is okay if the receiver is nearer to the transmitter. For example, if I take a printer will be placed nearer to the CPU. So at that situation, we can go for a parallel kind of a communication wherein the length of wire will be very less. So we can bear that cost compared to the speed, because we are getting an advantage of a high speed transmission, right? So this is about parallel. But when you talk about a longer distance, if you are transferring the data in terms of a meters or a kilometers level from one distance to the other distance, then if you want to transfer 8-bit, you need to have a length of cable which is going to have an 8 bits and it should be of a longer wire. So in that case, there is a chances of having a fault in the data, and also the cable length increases, which increases the cost of the system. To overcome this, we have a serial communication. So in serial communication, we will be having a transmitter as well as a receiver, but all these 8-bit data will be transferred using only one single line, one single transmission line. So one wire is enough to transmit the 8-bit data. But here the problem is, here the difference between the parallel and series is, we are going to transfer all 8 bits through one line. So first we have to, if you have a data like 0100 1000, so this is an 8-bit data. So one by one you have to transfer. We cannot transfer it simultaneously. One after the other we need to transfer. So here what's happening? The problem here is we have to compromise with the speed. Okay, we have to compromise with the speed, because first we have to transfer this, next this will be transferred, next this will be transferred. All are going to be transferred through the single line. But the advantage here is we need to have only one cable or one wire to transmit whatever may be the size of that bit, that byte, that data, sorry, that's data. It may be a 8-bit data, it may be a 16-bit data, whatever it is, it can be transferred through a single line. So that is why the serial communication is used widely in the microcontroller communication system, because it can be used for a longer distance. If the distance between the transmitter and receiver is a shorter, then we prefer parallel. But in microcontroller, we are preferring serial communication because of this advantage of having a single line to transmit all the bit. But we have to transfer it one after the other. That is the issue. And one more thing we need to understand here. See, when we are transferring 8-bit data, first of all, if I write some character like A, I want to transfer a character like A. Say if you want to transfer A, first it will be converted into its ASCII code. So ASCII code of A is 41 and it will be written in terms of a binary digits. So we get it as 0100 0001. This is binary representation of 41. Here we have 4 and 1. Okay. Now while transferring this is an 8-bit data. When we write this A, it is an 8-bit character, because microcontroller is an 8-bit processor. It is an 8-bit character, but we are transferring it through serially. So I need to get bit by bit. So what we need to do here is, first we have to convert that by using a parallel in serial out concept. We need to use a parallel in serial out shift registers so that all this parallel data can be converted into serially. And then after getting its serial output, we transfer the data. But definitely at the receiver side, we are going to receive serial data, but I want it in a bulk, in a parallel. So here at the receiver side, we need to have a serial in, parallel out shift register. So we need to have a converter which converts the parallel input into serial output and transfers the data, and then receives the data in serial, but finally I want it as a parallel here. So serial input will be converted into parallel, so that I can get the same signal what I have transferred at the transfer side and what I should receive at the receiver side. The same data should be received. So this is what the concept is. So here what I mean to say is, we need to have a special modem. In general we call it as a modem or a modulator or a demodulator. Okay, a special modem which converts this concept, parallel to series and then series to parallel. Okay, so that has to be done. And to achieve this, we have two different way of getting it. That is, in serial communication, we can get this by having two different parameters. That is asynchronous and synchronous. In the sense, in asynchronous, let's see what actually happens in asynchronous and then synchronous. In asynchronous transmission of a data, we consider 1 byte at a time. While transferring the data, we transfer 1 byte at a time. Okay, whereas when we consider the synchronous, we have to consider one sentence or one word or one character or one statement. For example, let me take an example to clear this concept here. Say there is a word called India. So I'll take a word now. I'll take one word like India. So this is the data what I have. I need to transfer it serially now. So let's see how this is going to be transferred when it is an asynchronous system and if it is a synchronous system. In asynchronous system, we consider this word India, and first it will take the letter A, the character A. It will be converted into, it will be written into 8-bit binary number, and this 8-bit of this character A will be taken first, and those 8-bit will be transferred serially, one by one. Once after completion of that transmission, next it comes to the another character I. It will consider 8-bit of this I and transfer that 8-bit one by one. So in this word, we are considering 1 byte at a time to transfer the data. That system is called asynchronous system. Okay. If it is a synchronous system, then we consider all these characters together. India, we take this A and we write it in terms of binary. Like A is 41, we write its binary 8-bit code. And I, its 8-bit code will be written. And this character D, its 8-bit code will be written. So we combine all the bytes of individual character, and then it will be made to transfer one by one. We are not going to take it separately. We combine that word. All 5 letters will be taken together and then it will be written in binary and then transferred serially. Right? That system is called synchronous. We are synchronizing all the bits, all the characters together. So we are taking 8 bits of this, 8 bits of this, 8 bits of this, 8 bits of all the remaining numbers, remaining characters, and combining it. Okay. For example, we have 5 characters. Totally we get 40 bits. All 40 bits will be arranged in a frame and transferred one by one. That is called synchronous method. If not, asynchronous means from this 5-letter word, we consider one 8-bit data at a time. 1 byte A will be taken in a frame and those 8 bits will be transferred. After that only we will go for the second character. I hope it is clear. See, asynchronous and synchronous. So microcontroller 8051 comes under asynchronous system. To do this means you need to make a decision whether you are going for an asynchronous system or a synchronous system. To do this, we can again write a program, but that will be a hectic case. To avoid this, again in market there are readily available chips. Okay, those chips are named as UART and USART. So it stands for Universal Asynchronous Receiver Transmitter, and this stands for Universal Synchronous Asynchronous Receiver Transmitter. Okay, we have these two chips in microcontroller 8051. We have, by default, we have UART chip, Universal Asynchronous Receiver Transmitter. It means whatever the character, whatever the word you write over there, it will consider 1 byte at a time, and after that taking 1 byte, individual bit will be transferred serially. That is called asynchronous transmitting of or receiving of data. I hope it is clear for you about serial communication, parallel communication, synchronous and asynchronous communication. Now let's move on. We have another part of communication which is need to be understood, that is a duplex, half duplex and full duplex. It's a general concept. I want to make it clear for you. See, communication can be done in a different manner. One is the simplex. Simplex is nothing but there will be a transmitter and there will be a receiver. This transmitter will send the data, receiver will receive the data. That is called simplex. It means one person will be speaking, the other person have to listen. He cannot speak back, he cannot talk to him back, right? That system is called a simple and a simplex system. Simplex way of communication. Okay, right. Next comes duplex. Duplex is nothing but you can do both. There will be a transmitter and a receiver. Okay, transmitter can send a signal and receiver can receive a signal. There is also receiver here and transmitter here. This transmitter will send a signal, this receiver will receive a signal. Look at this, what's happening here. Here both the side, both the person is going to have, assume that this is person A and this is person B. Both are having receiving and transmitting option. He can send a signal while he can also receive the signal. But one problem here is there is only one line to communicate. It means while A is transferring the data, let me put this direction properly. While A is transferring the data, B has to receive. He don't have any other option because he cannot transfer another data. If he transfers another data, then the data will collide here. The signal will be lost, right? So what we need to do is, when person A is talking, B has to listen, and when B is talking, A has to receive, right? So this is, but both the way communication has been done, but not simultaneously, one after the other. So it is a duplex, but not completely. So this system is called half duplex. The best example for this is walkie-talkie. Okay, you might have had an experience, or you maybe come across this example that we used walkie-talkie. Any traffic police people will use that, and there will be a communication going on. Once after they communicate, they use a word called over. So it is just an indication that whatever the information I wanted to share, I have completed. Over indicates that he completed his information. Now he is ready to receive the information. So you can speak. So person A will speak, and at the last he say over. It means that person B understands, okay, he completed the data. Whatever he wanted to transfer, he has transferred it. So B can speak now. Okay. So that code word over is used for that purpose, just to make it clarify that I have done my job. Now it's your turn to speak. That is how they are going to understand, or we can say adjust it. Okay. So this is what happens in a half duplex. Now let us come to the full duplex. So full duplex, in this sense, I hope you might have got an idea that what we are going to have in a full duplex. In full duplex, we will have both transmitter and receiver in both the cases, and also there will be a separate line. When this transmitter is transferring the signal, receiver will receive it, and B is transferring the signal, receiver will receive at A. So both can transfer the data simultaneously, and they can receive the data simultaneously. Okay. So a best example for this kind of a communication is, yes, you can think on it. Yes, it is a mobile communication, wherein it's not only just two person. We can also go for a conference call, and we can have an n number of people into that, right? So we can have the mobile communication as a best example for this, where I can speak and even the other person can also speak to me simultaneously, and both will receive the information signals without losing any signal. That is important. There will be no mismatching of signal. So this is how the communication has been improved, right? So whatever the communication we are doing in the microcontroller, keep one point in your mind, that is a serial port communication, and we are using UART, universal asynchronous receiver transmitter chip, wherein we transfer 8 bit at a time, bit by bit, but we consider 1 byte, and in that byte, bit by bit, we transfer the data. So this is all about serial communication. Now let us have one detailed idea how these 8 bits will be transferred. Means, if you want to transfer an 8 bit, there must be some information given to a system that yes, I have done with my 8 bit, I have transferred 8 bit, now you can go for the next one. So there must be some signal has to be given. So to do this, there is one pattern called data framing. So let us understand what is this data framing. Okay. So framing, the word indicates that the data will be given in a frame. If you want to transfer 8-bit data, so I will take an example like 1, 0, 0, 1, 0, 0, 1, 0. So this is an 8-bit data which I want to transfer. Okay. So this data, when you want to transfer this data, 8-bit data, we cannot transfer this data as it is. There is a start and stop bit concept used in this 8051. So that start and stop bit will be something like this. Say this is 0. Let me take this example. This is 1. Okay. Right. So this is high, and again we will have the bit like this. So this will be a start bit. There will be a one start bit which is low. We need to have a low start bit. So let me point it out clearly. So this is a start bit, and this is generally a low signal. Okay, and there will be a stop bit which is going to be generally a high signal, stop, which is high, and then we have a space, and here we will have a mark. See, what I have done here is I have this actual 8-bit data which is to be transferred serially, but this 8-bit data has been framed with some other extra parameters, like we have a start, means all this is D0 and this is D7. It means that whenever we are transferring a data, the LSB, least significant bit, will be having a start bit which is of a low. Okay, it will be having a start bit, one start bit, and MSB D7, that will be followed with a stop bit That may be 1 or 2. It again depends upon the manufacturer. Okay. So now I have shown just one stop bit, and that stop bit should be high and followed with a low bit, that is space. And here it is followed with, it has been proceeding the mark, that is high here. Okay. So when we transfer the data, first we will have a start bit. Okay. Receiver will receive the start bit. When receiver receives the start bit, he understands that okay, we are going to receive a 8-bit now. So after that start bit, the LSB will be transferred first. Okay, then next one, next. So when after receiving the D7, that is the 8th bit, the receiver will receive stop bit. Okay, this stop bit. So when receiver receives the stop bit, it understands that okay, first 8-bit data has been received. I have received 1 byte completely. Okay, so after that it will be ready, it will make itself ready for next 8-bit. Okay, so that is why we have to arrange all these 8 bits under this frame. So this concept is called data framing. Arranging the given 8 bit with a start and a stop bit is named as a data framing. So this data framing is important so that the receiving system will understand that I have received the data completely or not. Okay. I hope this data framing is clear for you. If this is clear, now let us move on for the next concept, that is just simple one important thing I want to tell you about the data serial communication, which we use it in a microcontroller, that is baud rate. Okay, so after transferring this package, I think now it is clear for you how we transfer. We are not going to transfer only the 8-bit, we are transferring with a start and stop bit. So totally if you want to transfer one character or one 8-bit data, we need to have 10 bits over there. One for start, one for stop. Okay. So now baud rate is important parameter in a communication system. That is generally we relate this with a BPS, that is bits per second. So it is similar to that bits per second. When you compare a modem, then baud rate and BPS will be different. But when you are using that wire through which we are transferring the data, then BPS and baud rate sounds same. Okay, so BPS is nothing but bits per second. Same way baud rate is nothing but how many bits we are transferring per second. That is the baud rate. So in IBM we have different baud rates like 9600, 19200, so on. Just double it. Okay. Then we have an 830. So it is going on. It will be a increasing number. Okay. Different baud rates we have. It's 9600 means per second the system is going to transfer 9600 pulses or bits together, one after the other, okay, per second. That is just going to identify or give an information about the speed. Okay, this is one important terminology which is to be known before writing up programs in serial communication. And one more thing we need to understand, that is RS-232. We make use of this RS-232. Here first question comes, what is this RS-232? What is that RS stands for? See, we have to connect a CPU with a microcontroller kit. So there must be a connection between those two. There should be a communication. So how we are going to connect? We are going to use a cable. So that cable is known as RS-232. So generally in the year 1960, the Electronic Industry Association like EIA, in the year 1960 have developed one communicating cable which will be common or standard which will be standard for all kind of a microcontroller. It may be a IBM product, it may be a Atmel product, it may be a Philips product, whatever it is. It should be commonly used for communicating with the all manufacturers or all microcontroller kits. Like, okay, so wherein RS stands for recommended standard. Okay, it is recommended standard 232 cable. In the year 1960, it has been developed by Electronic Industries Association, as I told you. And we have later in 1963, they made some changes in it and they named it as RS-232A, RS-232B. So they got some other versions of it. Okay. So one thing we need to understand, why this RS-232 is used. I told you that it is to communicate. but there is a compatibility. We need to match the compatibility of a microcontroller kit and a CPU. So this is CPU where we write a program, and there is a microcontroller kit. So we need to connect it. So that connection is done by RS-232. So compatibility is to be matched. The problem is microcontroller kit is a new versions, whereas RS-232 has been developed in the year 1960. The logic here used is not TTL, whereas microcontroller kit's logic, most of the logics are of TTL logics. They have developed it using a transistor logic, right? So the voltage operating for this will be different, and voltage operation of RS-232 is different. Like RS-232 will consider -3 to -25 volt as bit number 1, means -3 volt to -25 volt. If the voltage is in between this, then it consider it as a high bit. Okay, that is what the concept we have for an RS-232. If it is of +3 to +25 volt, then it consider it as a 0, low. Whereas microcontroller kit is not going to have that range. Okay, and also here in between -3 to 0, there is no range for that. But the range of microcontroller kit is different. So we need to match those two, right? So in order to match these two, we need to have another IC which is going to match these mismatches. Like its operating voltages are different. The bit in microcontroller, this is going to be different, right? So to match these two, to compatible between these two, we need to use MAX232. MAX232 is used to match the differences what we have in RS-232 and a microcontroller kit. It is required because the newer version of kit is made up of a TTL logic, whereas this is a older version, right? So MAX232 is another topic here. In next video, I will come up with a complete detail about this RS-232, what all the pins in that RS-232 will be, and how many pins it will be of, and what each pin is going to do. Okay, and also we'll have some brief idea about MAX232, how it is used and how it is going to convert all these things and adjust it. Okay, I hope till now you understood the basic concept of a serial communication. You keep watching my videos, and also if you are not joined my channel, especially this microcontroller video what I have done, it is for the members. Okay, so join my channel so that we can gain the knowledge in microcontroller. If it is clear, if it is very clear and understood, then please have a comment in it and also like my video. Thank you.